Hi, this lesson is all about starting to compare some of the geological features we find on the surface of Mars with um, equivalents or analogies that we can see and study here on Earth. Now, to be able to do this, we're going to have to apply one of the big ideas of geology, an idea that we looked at back in theme one. It's an idea called uniformitarianism. So, if you're perhaps a little bit hazy on the details of uniformitarianism, this would be a good point to go back to your Theme 1 booklet, read up about James Hutton and the ideas around uniformitarianism, or watch the little summary video that's linked in the lesson guidance notes. Okay, if we're secure with our understanding of uniformitarianism, let's think about these features. We're going to be looking at pairs of features that I've given you photographs of on pages 15, 16 and 17 of your Theme 2 booklets. The first job we need to do is to understand what these features are. You'll see at the top of each pair of images I've given you a title in capitals and a dotted line. What I'd like you to do is I'd like you to find out what each of these features are. Google them and come up with a one-sentence definition for each of those features. So press pause now and have a go at that. Okay, you should now have a set of definitions for each of those different features. Let's just go through and check what they are. So the first pair of images is of two volcanoes. Olympus Mons, that we've studied in some detail in Theme 0, and a volcano in Iceland called Herdbride. Now, volcanoes are simply places where magma erupts at the surface. So that's happened in both of these locations. You need to now compare these two. What similarities do they have? What differences do they have? And perhaps can we think about why these are like this? Why are they similar? Why are they different? The second pair of images is of two rift valleys. On Mars, we have a place called Claritas Rupes. The location of each of these places is shown on the map on page 14 of your Theme 2 booklet. And from Earth, we have a place called Karlsruhe in Germany. Both of these locations are rift valleys. These are places where the crust is pulled apart by tectonic activity. What we see then is a valley defined by faults, by cracks in the crust. Often these cracks are going to be parallel. So can you compare these two locations? What do these locations have in common? And what's different about them? The third pair of images is of dunes. From Earth, we have an aerial photograph of the Namib Desert in Namibia, and from Mars, a location called the Ablosundai. Now, dunes are ridges of sand formed by deposition by the wind. We can find them in deserts, we find them on coastal areas, Mirtha Mara, for example. Can we compare the sand dunes that we see in the Namib Desert with those that we find on Mars? What's similar? What's different? And why might that be the case? The next pair of images is of a much more detailed geological structure. This is a feature we call cross-lamination. Now, cross-lamination are layers within a bed of rock. They're formed by deposition by a current, either of air or a current of water. So this is by the wind or by, say, a river. Sand gets deposited on the downwind or the downflow direction of a big ripple. If you're not sure what these are, you will be able to find animations or experiments that have been done on the internet. You look at YouTube, see what you can find. We have examples of these from Mount Sharp, a Curiosity rover was exploring, and also a location in North Dakota. What's similar about these images? What's different about them? Our next pair of images actually looks at a sedimentary rock. It's a rock we call conglomerate. Now, you should have found out that conglomerate is a sedimentary rock that's formed of rounded fragments of rock, rounded pebbles, if you like. What are the similarities between the conglomerates that we can see here on Mars and the one we can see here on Earth? Look at the size of the pebbles. Look at the shape of the pebbles. Is there any organisation we can see in them? How do you think they've been formed? Our final structure is an unconformity. Now, these are important ideas in geology. We've talked about unconformities already when we were looking at James Hutton's work at Siccar Point. So an unconformity is a gap in geological time, often with evidence of erosion. We've got two images here, one from the Columbia Hills in Mars, another image from Curiosity, and a photograph from Death Valley in the USA. You need to look more carefully at these images, particularly the Martian one. It's a little bit subtle. But can we spot any differences? Can we spot any similarities between them? This was a big discovery. Okay. This is an image, to finish, of the volcano in Iceland, Herdebreid, looking at it from the side. See, it's a very distinctive shape. It's almost like a drum shape. Small cone on top, but the majority of the volcano is actually really very steep. The interpretation of this is that this volcano erupted underneath an ice sheet during the last glacial period. The ice cooled the lava, stopped it flowing away and forming the more typical shield-shaped volcano that we'd expect to find in Iceland. Makes it much steeper. Is that similar to Olympus Mons, I wonder? Anyway, what I'd like you to do now is think about how your observations of all these different features tell us about the application of uniformitarianism to our interpretation of Mars. How does it help us understand the geology of that planet? Next time, we'll start thinking about what Mars is actually made of. I'll see you then.